if f of n is equal to n multiplied by 2 to the power of n, then write f of n plus 1 in terms of n. Hence, show that f of n plus 1 minus 2 times f of n equals 2 to the power of n plus 1. So we're going to start off with writing f of n plus 1 in terms of n. That means we want n in our answer. It doesn't mean solve for n. So we go back to the function f of n that was given in the question. And since we're asked to add on 1 to the n, we literally just add 1 to every n that we see in f of n equals n times 2 to the power of n. So I'm going to add on a 1 here. I'm going to add on a 1 here to the n that was in front. So that n in front of the 2, I get a 1 added on. I must put brackets around it. The reason I've got brackets around it is because the n and the 2 are stuck together. And two things stuck together in maths means multiply. So I'm going to put brackets in to represent me multiplying by the 2. So the 2 stays as it is. And then this n here on top, this power, gets a 1 added on as well. So the n in front gets a 1 added on with brackets around it. And the n, that's the power, gets a 1 added on as well. Okay, so then we're going to use one of our laws of indices to break up 2 to the power of n plus 1. So we're going to use law 1, which states that a to the power of p multiplied by a to the power of q equals a to the power of p plus q. Or in words, when we're multiplying powers with the same base, we add the powers. So we're going to use this rule, but we're going to work it backwards to break up 2 to the power of n plus 1. So 2 to the power of n plus 1 is going to give me 2 to the power of n multiplied by 2 to the power of 1. So we've used this rule, but we've worked it backwards. So 2 to the power of 1, we can just write as 2. And then what we want to do is multiply out the 2 by the n and the 2 by the 1. So 2 times n gives me 2n. That's where that 2n comes from. And 2 times 1 gives me 2. And this is all multiplied by the 2 to the power of n. So that's why we have brackets around it. So f of n plus 1 gives me 2n plus 2 multiplied by 2 to the power of n. So we have written f of n plus 1 in terms of n. Now we're going to show that f of n plus 1 minus 2 times f of n is equal to 2 to the power of n plus 1. So we just found out a minute ago that f of n plus 1 is equal to 2n plus 2 times 2 to the power of n. So basically just swap this for this. We bring over the minus 2. And we know from the question that f of n is equal to n times 2 to the power of n. So we swap f of n for n times 2 to the power of n. And we must stick brackets around it because we're multiplying. Okay, so that's where this step comes from. Now, what I would like to do in a later step is I'm going to try and factorize. So in order to do that, I have to have something common to each term. So this is one of my terms, 2n plus 2 times 2 to the power of n. And then minus 2 times n 2 to the power of n is my other term. And I want to try and have something that's common to both that I can take out of both, so I can factorize. So if I multiply the minus 2 by the n, I'm going to bring out a minus 2n outside my bracket. And then I'm just left with the 2 to the power of n inside my bracket. And when I do that, I have a common factor to both terms. I've got 2 to the power of n, and I've got 2 to the power of n. And over here, all I did was swapped these around, because we tend just to have the single term outside the brackets. So I've got 2 to the power of n multiplied by 2n plus 2 as one of my terms. And then I've got minus 2n multiplied by 2 to the power of n as my second term. And I can see that my underlined values are my highest common factor. So I'm going to take those out and bring them down here. I'm going to factorize, and that's my HCF, that's my highest common factor. And then I'm left with the 2n, the plus 2, and the minus 2n. Then I can see that the 2n minus 2n will cancel out, leaving me with just plus 2. So that's where that 2 comes from there. So I've got 2 to the power of n multiplied by 2. 2 can be rewritten as 2 to the power of 1. So then I've got 2 to the power of n multiplied by 2 to the power of 1. And here I'm going to use my law 1 of indices again, which tells me that when I multiply powers with the same base, I add the powers. So 2 to the power of n multiplied by 2 to the power of 1. My bases are the same, so I just have to add the powers. I add the n and the 1. So I end up with 2 to the power of n plus 1, which is what I wanted to end up with.